Hi everyone, this is Kiranmai from H&S department. Today in this session, we are going to discuss about lasers. Under this topic, we are going to have population inversion, pumping and pumping mechanisms, laser action, and elements of laser. First of all, what is population inversion? Why it is important to get laser output? That is, population inversion is nothing but making the number of atoms in the higher energy level more comparable to the number of atoms in the lower energy level. If this condition has been created, then we can call that condition as population inversion. The states of the system in which population of higher energy state is more in comparison to the population of lower energy state, such states are called negative temperature states. And this population inversion can be achieved with two different schemes. One is 3-level scheme and another one is 4-level scheme. Whatever the output we are supposed to get due to these two schemes will be different depending upon the energy levels what we had chosen. Okay, so coming to the first scheme, that is 3-level scheme, by which we can achieve population inversion. Coming to the 3-level scheme, as in the name itself, it is specified three energy levels will be there. Let them be E0, E1, and E2, where E0 is the lower energy level, E1, E2 are the corresponding higher energy levels. If the collection of atoms are intensely pumped means we're just giving external energy. If they are lifted from lower energy level, a large number of atoms are excited through stimulated absorption to the higher energy level E2. If E2 is having shorter lifetime, which means that if E2 behaves like a normal energy state, then its lifetime will be about 10 power minus 8 seconds. So atoms will decay faster to level even. Once that energy lifetime is completed, atoms will decay fast to the lower energy level even. If E1 is having a longer lifetime, if it is a metastable state, then its lifetime will be about 10 power minus 3 seconds. So obviously they will stay there for more time, comparable to the E1 energy level. So more number of atoms will be accumulated in E1 energy level comparable to E2 energy level. So on the screen, you can observe the transitions from E0 to E1, just pumped atoms from lower energy level to higher energy level. From E2 to E1, since E2 is a normal energy state, atoms will decay faster to the E1 energy level. Since E1 is an metastable state, atoms will accumulate over here for more time comparable to E2. So more number of atoms will be there in E1 comparable to E0. Therefore, population inversion is created between E1 to E0. When intense pumping, even more populated than E0, hence the population inversion is achieved between E1 and E2, and laser transitions can happen between E1 to E0. Okay, and population inversion is created between E1 to E0. So what is population inversion? Number of atoms in higher energy level is greater than number of atoms in lower energy level. So N1 is greater than N2. If it is reached, stimulated emission rate exceeds stimulated absorption rate. Therefore, pulsed mode of outputs can be obtained using this 3-level scheme. And the best example for this scheme is ruby laser. Okay, why pulsed output? Because since all the atoms from the E1 energy level should come back to E0, where they are again ready for the pumping to E2 level. So this process will become little bit late because E1 is the metastable state, just above the ground state. Hence the process will become slower. Therefore the output will be a pulsed output. But if you want to make a continuous output, just introduce one more energy level in between these E0 to E1. If you introduce one more energy level, the process will become continuous and you'll have a continuous output at the output as the laser. For that, just go for the next scheme, that is 4-level scheme, in which 4 energy levels will be there: E0, E1, E2, E3, where E0 is the ground state, and E3 is the normal energy state. E2 is a metastable state. Again, E1 is a normal energy state. One energy state we had introduced in between ground state to metastable state. Okay. In this figure, you can see that this is the metastable state and this is the ground state. We had introduced one more energy level in between metastable to ground state so that the process will become continuous. Now, from due to pumping of atoms from the ground state, all the atoms will get pumped to highest energy level, that is E3, where it is an normal energy state. So atoms decay to the metastable state E2, where the atoms will get accumulated. Hence, the population inversion will be created between E2 to E1. So laser transitions takes place between E2 to E1. To have a continuous output, what we should do, this E1 should be a normal energy state, so that the transitions from E1 to E2 should be E0, E1 to E0 should be faster, so that atoms will be ready for the pumping from E0 energy level to E3 energy level. If this E1 to E0 transitions are slower, what happens again? You'll get pulsed output only. So to make it faster, E1 should be an normal energy state, so that atoms will decay from E1 energy level to E0 energy level. And the best example for the continuous output laser is helium neon laser, where the energy state between metastable and ground state is a normal energy state. Whereas for N2 laser, you are supposed to get, it's also N2 laser is also a 4-level scheme. But the thing is, we are going to get pulsed output, because the energy level between E2 to E0. E2 to E0 will be a metastable state. If this is a metastable state, again the process will become slower. So this then the output will be a pulsed one. Then coming back to the pumping, as we had discussed, used a new term called pumping. Pumping is nothing but lifting atoms from lower energy level to higher energy level. Just lifting the atoms from lower energy level to higher energy level by giving external energy. By giving external energy, if an atom is lifted from lower energy level to higher energy level, then the process is called as pumping. So this providing in external energy will be of different types depending upon the provision of external energy. Pumping schemes are of 4 types. One is optical pumping, electric discharge method, chemical reaction method, injection current method. Out of these 4 methods, optical pumping is used in solid lasers, electric discharge method is used in gaseous lasers, chemical reaction method, and then injection current method is specially used in semiconductor lasers. So first of all, what is optical pumping? So optical pumping is nothing but giving external energy in the form of light. Optics, light, if you had provided external energy in the form of light energy, then such sort of pumping is called optical pumping. If the atoms are excited or lifted from lower energy level to higher energy level by taking light energy, by absorbing light energy, then such process is called as optical pumping. And solid lasers are optically pumped using xenon flash lamps. Since these materials have very broad absorption, sufficient amount of energy is absorbed from the emission of bands from the flash lamp, and population inversion is created. The best example for optical pumping, what we are going to learn in the next sessions, that is ruby laser. Then coming to the second process, where you are supposed to use chemical energy. Chemical energy means, as we had in the chemistry, I think you may have discussed about 2 different reactions, exothermic and endothermic reactions, where exothermic is the chemical reaction where energy will be released after the reaction, and endothermic is the process where you are supposed to utilize the energy before the reaction itself. So in this chemical reaction method, we are supposed to use exothermic reactions. Once the exothermic reaction has happened, energy will be released. That energy is supplied to the atoms in the lower energy level, which are lifted to higher energy level. And the best example for this process is carbon dioxide laser. The third process of pumping the atoms from lower to higher energy level is electric discharge method, where by using the electrons which are released after the electric discharge method, those electrons collide with the atoms in the lower energy level and make them to excite from lower energy level to higher energy level. Such process is called as electric discharge pumping mechanism, where population inversion is achieved by direct excitation as it occurs in a electric discharge method. And the best example for this one is argon ion laser, and one more example is helium neon laser, which we are going to discuss in the future sessions also. In some lasers, one type of atoms are excited by electric discharge method, and while they are de-excitation, they will collide with other atoms and make them to excite from lower energy level to higher energy level. The best example for this process is helium neon laser. The fourth process by which we can pump the atoms from lower energy level to higher energy level is injection current method, where in some semiconductors, lasing action is produced by conversion of electrical energy into light energy, in which recombination of electron and holes will occur. And the best example for this one is gallium arsenide laser. Coming to the lasing action. Lasing action means how would we get laser output? So to get laser output, first of all, we should choose a proper material. After choosing the proper material, by providing external energy, we should pump the atoms. We should lift the atoms from lower energy level to higher energy level. Once the atoms got lifted to higher energy levels, we should create one condition called population inversion, so that stimulated emissions will happen. So that population inversion means we should make the atoms in the higher energy level greater than the atoms in the lower energy level. If such condition is created, then the atoms will go for stimulation. Once the atoms go for stimulation, due to stimulated emissions, 2 photons will be released. So what happened here? Single photon incident on the higher energy level atoms produces 2 photons. So number got doubled. These doubled photons are feeded back into the medium, which is called as positive feedback. These 2 photons, again, they will try to interact with 2 more atoms in the higher energy level. Hence, these 2 photons will get doubled. That means the 2 photons will become 4 photons at the output. Each transition will provide 2 photons. So 2 photons interact with 2 atoms. So 2 transitions will give you 4 photons at the output. So what happened there? Higher amplification is happened. Again, the process will go for positive feedback. 4 photons again react with 4 more atoms in the higher energy level. So 4 transitions happen. Again, 4 transitions release 8 photons. So the number is getting doubled easily, which is called as higher amplification. Once the required intensity is reached, we will take that as laser output. So this is the process where we can go for choosing of proper material. After that, lifting the atoms from lower to higher energy level. Then we will create a condition called population inversion, where atoms in the higher energy level will be greater than the number of atoms in the lower energy level. Then once the population inversion is created, then it go for stimulation. Stimulation means 1 photon will get doubled as 2 photons. This 2 photons, which means that amplification of photon is happen. Those 2 photons are feeded back into the medium, so that those 2 photons will go for 2 more transitions. 2 more transitions means 4 photons will be released, which means the higher amplification. This process will be continuously done till the output of required intensity is reached. Once required intensity is reached, we can take it as laser output. This is the process what had been followed in different lasers, what we are going to see in the future sessions. Then what are the parts of laser? How to construct a laser? So for that, there are four main parts for the construction of lasers. First one is active medium. Active medium is nothing but the material what we had chosen for the construction or for the laser output. So active medium is a collection of atoms or molecules that can be excited to a state of inverted population. The 2 states chosen for the lasing transition must possess certain characteristics. First, atoms must remain in the upper level for a relatively longer time to provide more emitted photons by stimulated emission than a spontaneous emission, which is nothing but creation of population inversion. If that population inversion is created, that is N2 greater than N1, obviously stimulated emissions will be predominant than the spontaneous emissions. Second, there must be an effective method of pumping atoms from the highly populated ground state into the upper lasing state in order to increase the population of higher energy level or over the population of lower energy level. This can be done by choosing a proper pumping scheme with respect to the material chosen. Whatever the material chosen, depending upon that material, we should choose a proper pumping scheme so that atoms in the which are more populated in the lower energy state will get depopulated to higher energy states very easily. The active medium may be a gas or a liquid or a solid material or a junction between two slabs of semiconductor materials. It is of any form like a gas, liquid, solid or a semiconductor material. Now coming to the second part of the laser construction, that is pumping mechanism. So depending upon the material chosen, a pumping mechanism should be chosen. The excitation mechanism is a source of energy that excites or pumps the atoms to the active medium from lowest to higher energy state so that population inversion is created. In gaseous and semiconductor lasers, the excitation mechanism usually consists of electric current flow through the active medium, which is like electric discharge method or ion injection method, whereas in solid and liquid lasers more oftenly we are supposed to use optical pumping. Coming to the fourth part of the reason part fourth part of the laser, that is resonant cavity. As I told you, in the lasing action, whatever the photons which are produced due to stimulated emission, we should feed them back into the medium, which means that we should make them to come back into the medium by some sort of means. That means is called resonant cavity. This feedback mechanism returns a portion of coherent light originally produced in the active medium back to the active medium for further amplification by stimulated emission. And usually it consists of two mirrors, each one at the end of the active medium, aligned in such a way that they reflect the coherent light back and forth through the active medium. Coming to the laser action, when the excitation mechanism of laser is activated, energy flows into the active medium, causing atoms to move from ground state to certain excited state where the population inversion is created. Some of the atoms in the upper lasing level spontaneously emits incoherent photons. When these photons travel along the axis of the medium, produces stimulated emission. Hence, the process will continue by positively feeding them back into the medium. Thank you.